zoom in here a little. So today we're going to be looking at relations and functions, and that is going to be page 56. It's 2 pages like normal. So when you're putting it in your notebook, the title page on the left, the other page on the right. Okay, so pause if you need to take time to glue that in. So today when we are talking about these, we are really talking about a relation, okay, which is a set of ordered pairs, but can be represented in multiple ways. Okay, so we can take those ordered pairs and we can represent them in multiple different forms. So while we might say it's a set of ordered pairs, that ordered pairs can be represented in different formats. So for example, if we are given ordered pairs, we should be able to take those ordered pairs and put them into a table, right? So we can do that by just looking at the ordered pair 1, 2, and knowing that that means a 1x value matches up with the 2y value. 3, 7 is 3, 7. -4, 6 is -4, 6. Okay, and similarly, we should be able to do that in reverse, that if we were just given the table, we should recognize that this is 1, 2 as the ordered pair. Now, that one's probably pretty common. You've heard of that before. The next one is not as common. It is called a mapping. Okay, a mapping is where we are going to list the domain in the left-hand bubble, or our x values over here, right? We said domain and x values are the same way, are the same thing. And our range or our y values over here on the right. Now, the key is that when we list these, okay, there can be no repeats, and they have to be in numerical order. So you have to create this a very specific way. No repeats and in numerical order. So when we're going down our x box, we want to take all of these x values, but we have to list them in numerical order with no repeats. Okay, so from least to greatest, -4 is the smallest, then -2, then 0. But because that one shows up twice, we're not going to list it twice. We're only going to list it once because we cannot list a repeat in the bubble. Okay, then we're going to do the y's. So same thing, not quite as easy numerical order here. So -2 is the smallest, followed by 2, then 6. Now we see 6 again, but we can't write it down, and then 7. Now, I can have -2 and -2 because those are in separate bubbles. I just can't have a repeat within the same bubble. Okay, then I'm going to take that info and I'm going to draw a line from each x value to y value. Right, so like think of this as the ordered pair -4, 6, right? -4 goes to 6. Man, sorry, I'm hitting my cable that goes to my camera. -2 goes to +2. 0 goes to 7. 1 goes to -2, and 1 also goes to 6. Okay, this can also be represented in the coordinate plane by graphing those points. Now, again, a relation is a set of ordered pairs, but that ordered pair might not be given to us in what looks like ordered pairs. So we should be able to do these mapping backwards, right? This is -4, 6. This is the ordered pair -2, 2. And 1, 6. So we should be able to plot those points. We've already talked about plotting in the coordinate plane, so that should be easy enough. -4, 6. -2, 2. And 1, 6. No connecting lines, no anything like that. Right, we did that in the activity, but this is just plotting the points that exist. We only know that there are 3 of them. Now, we already know that the domain is the x value. We've already talked about this statement before, so this part isn't going to be new, that the domain is the x values. But when we list the domain, we always have to list it in braces, which it says up here above, and in numerical order. But I want to make sure we are good on that. So we are doing the exact same thing for the range. The range is the y values. In braces, right, same, and in numerical order. We have to follow those pieces for each thing. So if we want to list the domain, we are going to be listing our x values. Okay, and when I list them, I'm going to be listing them in numerical order. So that's -3, 2, 7, no repeats, so I can't list that -3 twice. And in braces, if you're not good at making braces, just draw a squiggle. It cannot be a parentheses. Do not substitute it with a parenthesis. Okay, so our range is going to be our Y values. Again, in numerical order, so 5 is the smallest, but we can't list that repeat. And in braces. Now, when we list the domain and the range, that doesn't allow us to go back to these other forms we've looked at because this doesn't show us what X value matches with its corresponding Y. Now, all of these representations work for any type of relation. They all work. Okay, but there is a special type of relation that we can talk about called a function. Okay, and in a function, each element of the domain, each of the X values, can pair with exactly one element of the range. One element of the Y value. This is a really fancy way of saying that the X value can't repeat. Okay, so functions are special types of relations. They are relations. They just have to have an added characteristic that the X value does not repeat. Okay, so if we want to decide if these below are functions, we're going to look and see if the X value repeats. Okay, so if we look at this, we're looking at the X values only. The Y doesn't matter. That's not important. Do we see any X value repeat? No, we don't. So if the X value doesn't repeat, yes, it is a function. Right? They're all relations. We know that. Now, we know we made a rule over here that when we're making the mapping, there can't be a listed repeat. So we're not going to see a repeat listed in here. Instead, we're going to look and see how many arrows we have coming from it. So we'll notice this -1 has 2 lines coming from it. So that X value is used once, and now it's used twice. So this is not a function. Okay, and then we will look at our last one over here, our last table. If we look at this, okay, we're going to see if we see any of the X values repeating. So the Y values don't matter. This is irrelevant. We're looking here. Do we see any X values repeat? No, we do not. Okay, negatives and positives are not the same number, so yes, this is a function. Okay. Now, graphs are a little bit trickier because on graphs, we don't see those numbers to see if they actually repeat. So we have to use something instead called the vertical line test. Okay, our vertical line test, it tells us exactly what to do. It tells us to draw some vertical lines and see if we will hit the graph more than once. So I think the easiest way to do this is to take either your pencil or the edge of a sheet of paper, okay, and think about any place you could set this paper down, right? We're vertical lines, so we're thinking about any vertical lines happening. Is there any place that the edge of this sheet of paper will touch this graph twice? Well, right now, right, the edge of my sheet of paper is touching my graph here and here, so it is touching twice. Okay, if it touches twice, it is not a function. It's just a relation. It's not a function. Okay, we'll do the same thing on this one. We'll go all the way across. Well, it touches once, right? Every place, every vertical line, the edge of my paper can only touch this once. I can't hold my paper this way. It's not the horizontal line test, just vertically. Okay, it only touches once, so this one is a function. Okay, I'm gonna look at our last one here. It's only touching once. So this is all touching once. So this is a function.